So, door kickers, which is basically you are a team of squads, you are a squad, not a team of squads, you set up your plan, and there's enemies, and depending on the plan phase, what you have those guys to do, okay, like this, they will execute the plan, maybe kill something, maybe get killed. Obviously there is some tactical elements to that. So yeah, that's the idea, and we can see, let's see how to make this. We are going to make this in 3D because it's much easier than making it in 2D. So here we are. Now, if you haven't played that game, I suggest that you at least watch some videos of it. It's really easy to grasp and to get the idea, but for us and for what we want to do, we are going to try and basically copy the mechanics almost to the letter, but translate it in 3D, although for the most cases it's still going to be the same. It has some very specific ways of moving and interacting with the world, so yeah, I suggest at least either play it or see some videos of it. And I mean about the first Door Kickers game. The other one I think is yeah, I think it's a 2D scroller or something, I don't know. Anyway, okay, so first things first, we do have our level, okay, just a basic level. Actually, this part is just a copy of the first level and just added 2 more rooms just so that we can have doors and stuff like that, because there's no way I'm going to make more levels. Okay, so I have my floor and my props, and for now I'm just going to select everything that can be here, and I'm going to set it to static. We are going to change a few things later. For example, doors should not be static, obviously. The idea for this is that we are going to make a nav mesh. Okay, let's make the engine radius kinda smaller, so it's a little bit more tight, so we have room to move. So we'll be moving around this. Okay, we're not going to bother about jumping through things and stuff like that. All these fancy things are not our cup of tea, at least not for this game. So we now have a movement, so let's start working with our units. Let's pick one of these guys. The other one will be the enemy, so it doesn't matter. So I'm going to create a folder for units. We are going to need for managers. Before I set up the unit, I think I already know what it's going to need, so I'm going to set those up as well. I'm creating an empty game object. I'm going to say unit, I'm going to add it below, and I know for the fact that this is going to have a capsule collider. Because it has a collider, it's going to need a rigid body. Okay, and I'm also going to use a nav mesh agent for this. The radius can be smaller. Let's enable gizmos. Radius can be about 0.3 or 4, I guess. Let's do 3. And we'll see. I do have an animator to this. Is basically a copy of the top-down animator, which let's see. Yeah, I can get. Yeah, okay, here it is. But it's a copy. But I think we're only going to be using walks. Okay. Because it's kind of a specific game, although I think, yeah, okay, we are going to have to replace these animations, but for now we can use them. And we might only need 1 or 2 animations for this. We'll see. I don't really care at the moment. So we have the base for what we need. Let's create a unit. Let's call it unit controller. Let's open this up. And let's hold on until this kicks in. And here we are. Now, we are going to need a few things. Obviously, we are going to need an animator, both a component and probably an actual animator to make some animations, but we do not have those luxuries. So we are also going to need the navmesh agent, which both we can get on start. Get component in children. And agent get component navmesh agent. Let's make it to get component in children as well, just in case. So at first we're going to see how we are going to be controlling, how are we going to be setting rules, and then we're going to bother with setting up tasks and what needs to happen. Let's create a new, I think we already have the folder. Yeah, we do have the folder, and I'm going to name this mouse operations. Create script, create mouse operations. So, okay, let's open up our script. And then, first of all, we are going to need array camera dot main screen point array input dot mouse position and array cast. Okay, so this will be doing arraycast. Now, in this case, if there is an input get mouse button down 0, and I think maybe we can just put this on top. Okay, so then we're doing the raycast. Let's find our unit controller, but first of all I need to know if this is public bool is player. Okay, so we're going to say unit controller hit.transform get component in parent or whatever unit controller. Okay, if unit controller is not null, Then we're going to assign the current unit. Okay, so current unit equals unit controller. Now, otherwise, we're going to tell if current unit not equals null. We're going to tell to that unit to move on to position. So we're going to say public void move to position. Now this is very basic so far. Keep that in mind, because we have a lot of things to do and we are going to change a lot of things, especially how we move and how we are doing the movement ourselves. So that will say set destination target position. Okay, so current unit dot move to position hit dot point, but here's what needs to happen. This needs to be sampled target position as nav mesh. So that will be nav mesh dot sample position, and it's a bool. So we want to say if nav mesh sample position, the source position will be hit dot point. We need a nav mesh hit. Maximum distance, let's say 1, and area mask, we don't care. And if we hit something, let's see. Yeah, we kind of need to add those positions, and this will be nav mesh hit dot position. Okay, so let's test this out. Let's set up our guy over here, unit controller, is player. Let's hit play. Now we do not have a selection and we do not have the mouse operations actually. Okay, and actually when we select, let's say debug.log character selected. Okay, character selected, and we can click and they will go where we tell them to go. Obviously that works for an RTS or maybe a Diablo style game, but we kind of need to be setting up positions and not and not just straight up walking where we tell them to go, which is something we're going to fix on a second stage. For right now we're just going to make him actually walk and do stuff, and then we're going to focus on making it exactly like it is with making it exactly like it is with door kickers. So update, move to position. Now we have to decide if okay, let's make a flag. So we're going to make bool flag or move flag, and I'm going to say move flag equals true. If move flag and if agent dot has path, if agent dot remaining distance is lower than agent dot stop distance, stopping distance, move flag will be false. While flag is on, we're going to take the desired velocity for this, vector 3, dv, desired velocity. We're going to make it relative to our own transform. What's this? Vector from wall space to local space and away. And we want this from wall space to local space. Okay. Now it's relative, which means we can set this to our animator, which I think we have named our parameters. Forward and sideways, okay. This will be the Z. Sideways will be the X. Okay. Obviously we can have downtime and stuff like that, but we just want to see that move flag is actually working. If move flag is off, so basically we could say this, we could do float H or F 0, float sideways 0, F and sideways, so F will be Z, S will be dv.x. And that's how we can handle moving and animations all together. So let's encapsulate this. Void handle moving, independent of what everything else is doing. Okay. Minimize that. Okay, he goes. One small issue. We have root motion enabled. We can deselect it from here, but it will be a little bit safer just to do it from here. So animator.update, not update, apply root motion set to false. And I think maybe we're moving way too fast. So let's lower the speed of our unit to maybe set it to 2. Okay, we're going to make them later to be specific to the animation, so it doesn't matter. Okay, that's too slow. But you can see, because we have now our desired velocity like this, and it does rotate via the agent, it will play based off the desired velocity. So that's something we can actually use. Okay, we wanted this. So that's for moving the unit. But of course, we don't want to just move the unit. We actually want to set up a path for the unit. So let's create a new class, which is going to be path step, or just step, I guess. Which is going to be holding a few data. For now, it's not going to be a model behavior, and it's going to be system.serializable class. So let's say public vector 3, target position. Okay, we're not going to bother right now. We're simply going to set up a list of steps, and we're going to be creating them. So we're going to make this as path or unit path or unit timeline, I guess. Let's call it timeline. And this is not going to be, yeah, actually, you know what? We don't need to be using this here. Delete this and just go directly on the unit controller. And we're going to add a public list of steps. Okay, and instead of moving into a position right away, I'm going to say public void add step. Right now we only have one type of steps. So that will be step equals s new step s dot target position will be the target position you have, and then on your steps you're going to add the s. Now we're going to have a method that actually executes those steps. Execute step. Okay, so inside update and inside handle moving, I guess. Actually, the only thing we need from here is this, because with this we know that we are at the end of our steps. So we're going to have just an index. I'm making it public so we can see it from the inspector. Okay, so when you reach your step, we're going to add on that step index, and if step index is lower than steps dot count -1, then we're going to say steps, or actually move to position steps I dot target position, not I, step index. Okay, else steps dot clear step index equals 0. Okay, so execute steps will basically take the first step and then move it to position. Onto our mouse operations, let's add a public void execute operations or execute steps. Okay, and for now we can just set current unit execute steps. We are going to need 2 units, and we'll do it after we see that this is actually working. Okay, for this now I'm going to set up a button. Let's set the resolution first, and that will be, let's see, 1080, I think 720, that should be enough. Let's call this execute plan. And just put it down there. Okay, so let's hook this up to our manager. And let's call this execute steps. Oh, now of course we won't be seeing the steps. And oops, yeah, we forgot to change one thing inside update. Instead of move to position, we're going to say add step. Okay, it won't show, but when I execute the plan, you'll see this guy going through one, and let's see. I think he's missing a few steps. Step index, step index, step index. Okay, so he did go the first one. But you know what? Let's not do an index. Let's remove the index entirely. And we're going to say if steps.count is higher than 0, move to position 0, and steps dot remove at 0. Because move to position is going to set the flag move again. Okay, and I think this might be the culprit, that we are setting a new position, but we are still having a path. So let's say agent.hasPath equals false. Yeah, okay. Agent.path. I think it's clear corners. That clears them. Let's see, agent.find closest edge, current complete of mislink, path status, resume, reset path, or reset path. It's one of these anyway. So reset path is going to make it so that it doesn't have a path, and we can check this. So it will be false, so then it will play. But whenever we do the move to position, we should be adding this as well. So keep in mind what's happening in here on our steps, and they should be, as we go through them, they should be removed. They should be removing. Execute plan. And they actually didn't. That's weird. I think we just never come in here, because we didn't get the hash path as well. And let's see, yeah, of course, with stopping distance at 0, we never reach that. It just auto breaks, because I think auto breaking goes with a distance variable. Now it should be done. Yeah. Okay, so we go step by step, and we basically play the paths we want to set, and we can keep adding more and more. Now obviously we do not visualize any of this, so let's fix that. First of all, let's add a line renderer. Okay, and let's call it path or steps viz. Then on our mouse operations, and actually each unit will have its own path viz. And whenever you're adding a step, you're going to go on your path viz, and we're going to be adding a position. Set position, and yeah, I guess set position path viz dot vertex. I think we need to set them up again. So for steps dot count, and then path pathvis dot position count set get the number of vertices, number of positions, that's deprecate. Okay, so steps dot count, then pathvis I dot set position I steps I dot target position. Okay, on start you're going to instantiate the pathvis.game object as game object, and then on that pathvis you're going to say get component pathvis. Okay, so it's going to, or line reader, so it's basically going to copy the prefab. Awesome. So let's see how we are on time. Okay, we're good. Now on to our mouse operations. Let's make this into a singleton. Okay, and I want to have a list of unit controllers, player units, and I want to have a register, public void register unit. And then whenever we execute the actions, instead of a single unit, we're going to be executing the steps for everybody. Okay, so on the unit controller and start, first of all, if you are the player, we want you to spawn something. And then we're going to say mouse operations, singleton, register unit this. Yeah, of course, we need to set up two, and we need to set the line renderer. Let's set this up, and let's make this kind of smaller. Though I think maybe it's too small even. And I want to tick use word space to this. Okay, cast shadows off. Also, do not receive any shadows. So I'm going to duplicate this guy. We can have as many as we want, doesn't matter. And let's hit play. So select one guy, set its positions. As you can see, we are a bit higher up. Well, they do not get visualized below. It's either that, oh yeah, it doesn't visualize the first step. So we need to go onto here, set positions, plus vector 3 dot up by 0.1 f, or 0.5 of that. Okay, but first we're also going to say +1. I will start at 0, and the first position of our path will always be around transform.position plus vector 3 dot up, and that is horrible. So let's also say offset vector 3 dot up by 0.05 f plus offset, and plus offset. Okay, we can also have this to be its own method. Update steps, this. So whenever we are actually updating this, they do get updated as well. Save that, minimize, and now let's try this again. Okay, and whoops. Okay, so why the first position is at 0? Transform position plus offset, because offset it's vector 3 up. Yeah, okay, that doesn't make much sense, to be honest. This is the unit controller. All of these guys are at 0. Damn it. Well, we'll see. Let's select one of these guys. Don't know why. I think it goes back to 0. Let's see it. And I think it has, yeah, okay, I know what it is. Because we need to clear first all the positions. Pathvis dot number positions equals 0, or position count, or does it have big mesh, broadcast, compare tag equals get positions, get property, get type, hide flag is visible, no, position count, pro banker, receive shadows. Yeah, okay, let's try this and we'll see. Technically this should have worked like this, but whatever. It should have give you 0 positions and it should have set them anew. So that this is working, but it's removing the last one. So I think it should be step.count, and yeah, I think that's better. Anyway, I don't know why the first thing is doing, the first part, but you can see that I can basically set up positions all around. But there's another issue that we will have to address in the future. They just point onto the paths. They do not point, let's see what this is. Set position count. Yeah, okay, let's say we remove this and we'll do position count like that. I minus 1. Now it doesn't even show at all. Actually, let's set steps viz to 0. it does keep the first one. Okay. Let's set this to 0, but I think that should probably override this. Don't know what's going to happen. Okay, so let's not update the step with when we are running this, first of all. And next, let's see, we have our position count. I think technically that should start from 1, because this set position, yeah, I don't get it. I really don't get it. See, this starts at 1, which means it's going to set it at 1. Maybe let's say step count less or equals. It will give us. It's either I'm tired or I don't get it. Well, there's another way around. There can always be, we can always remove this, have this start at 0, and on start, add step, transform to position. This can always start like this. So you'll be starting with 1 position already. And yeah, now it works. Okay, so you can execute the plan, but I think it skips the first part, however, and of course there are some other issues that we need to address, but we'll get to them on the next part or on another part altogether. Okay, so we see that we do set up the path. The first position, however, because we want to visualize it like this, we see that if I hit execute plan, because it's his own position, no matter which of these guys is, doesn't matter. Okay, let's select this guy. Okay, so the first position, and say execute plan. He removes the first one, but he never moves because it doesn't need the path, because he's already close to that path, and so on and so on. So that's another case that we have to address, which is if when adding the step, the move to position, let's say float distance steps 0 dot target position and your own position, if distance is higher than the agent dot stopping distance, then do this. Else, so cut this, paste this in here. We can actually do this recursively, I guess. We can say if it's higher, else. Yeah, you're still going to need this. You're still going to need to remove that step. but and we have steps.count greater than 0, then move to position. Now this is kind of terrible because we should be first checking if it's close to the previous point when we add the step. Okay, so yeah, okay, let's do it like this. So before you create a step, you're going to find the distance from vector 3 dot distance between target position and the steps dot count -1. Dot target position. If that distance is lower than the agent dot stopping distance, or it's higher, not lower, then add a new step. Okay. Or if steps dot count, this needs to be higher than 0, else add them back again. Now that's kind of terrible, but we're going to fix it anyway, because not all steps are going to be movement, so it doesn't really matter. So that means we can delete this, this, and this, and this. So that minimize, let it compile, and we're going to start working. So select this guy, move around, select this guy. I'm going to click near him, and as you can see, well, you can't see because he doesn't do anything. I don't know which this guy is. Yeah, it's this guy. Clicking near him, okay, does nothing if it's too close. If it's really close, then it's going to select him. But clicking away from him will actually start adding positions. Same with this guy. Now the other issue is that if I click inside here, obviously he's not going to go directly through the wall, but he's actually doing a pathfinder. If we set up the navigation and select our guys, we will see their actual navigation path inside Unity. Okay, and you will see that you will see exactly where he goes. So they do have pathfinding, and they do have, positions as to where they go and what they do. So we need to find a way, which I have thought of a way, where we're actually going to control their exact paths. Okay, there are multiple ways to do this. So we're going to first start with the most simplified one. But before we do all that, okay, so I don't know how much you heard of that because the video got freeze. So as I was saying, on the next part, we're going to bother about adding events, because it's not only about going onto those positions we set, even if we just now, it doesn't indicate the actual path you're going to take. And yeah, it's also about waiting for the other guy and having them all being synchronized and stuff like that. Okay, so that's it for this part. As always, you know what to do. Like, subscribe, and if you like to see more stuff like this, more series, more of everything, then consider supporting me on Patreon so we can keep making all of these. I'll see you next time.